Hello everyone, welcome to my channel. So in this video, I'm going to discuss the topic numerical method. Kindly focus on solutions of nonlinear equation and also the Newton-Raphson method. So now, what is the use of Newton-Raphson method? The purpose of using Newton-Raphson method is to estimate or approximate the root of the equation. As we can see, this is a non-linear equation where we have cos x minus x. So there are three types of strategy that we can use to estimate or to approximate the root. So number one, where we have the graphical method. So kindly focus on the situation where we have cos x minus x equals to 0. So where we have the function fx. So my suggestion is to split the situation. So we will have y is equals to cos x and y is equals to x. Next is to sketch the graph. So as we can see, y is equals to cos x. So the graph will be something like this. So based on the domain, as we can see, sketch the graph based on 0 until pi. So means that we have to stop over here. So meaning that this one is the extra one for the right hand side. Next, what we have to do is to sketch the graph for y is equals to x. So where we have y is equals to x, which is the linear graph, passed by the origin. So here will be the root. So from the graphical method, so from the graph, we notice that the root lies in between 0 until pi over 2. So that is the graphical method to use to approximate the root. Next, we are going to discuss the second method, searching for sign change. So previously, we already have the function where we have cos x minus x equals to 0. And we can transform them become fx is equals to cos x minus x. So here we have the situation. So for the method searching for sign change, meaning that we have to substitute the value for the x. So let's say, before we substitute, do remember must set the mode in the calculator radian, because it deals with the trigo function. Do remember must set in the mode radian whenever we deal with the function in trigo. So let's say the starting is 0, because we know that the function is in between 0 and pi. So let's say we have 0. If we press the calculator, it shows a positive value, which is 1. Next, followed by pi over 2, and we notice that we have a negative value. Notice that we have a negative value. So we can see that opposite sign show that there is a root in between x equals to 0 and x equals to pi over 2. So here we have another method to find the roots of the equation. Or we can say approximate or estimate the root for the equation. So the third method will be the Newton-Raphson method. Next, what we have to do is to repeat the situation. First, you must have the equation, followed by finding the f prime x or the first derivative. So differentiate cos, we will have negative sin x. Differentiate negative x, we will have negative 1. Next is to find the initial value. So previously, the root is lying in between 0 and pi over 2. So in order to find the x naught, we have to find the midpoint between the two values, where we have 0 plus pi over 2 over 2. So the x naught will be equals to pi over 4. So here we have the initial value. Next, repeat the situation. So here we have the formula x sub n plus 1 equals to x sub n minus the function f sub the value xn over f prime x sub n. So do remember, the calculator must be in mode radian. Then we substitute the situation and press the button calculate, key in the value pi over 4, and we will have x1 is equals to 0.739536. Repeat the situation until we have the repeated value. So means that when we have the repeated value, then we have to stop. And we must state the root x is equals to 0.7391. So that is the method for looking or estimate or approximate the roots for this equation. So where we have three methods, number one is graphical method, followed by searching for sign change, and the third one is the Newton-Raphson. So here we are, and thanks for watching.